So let's find it out whether these languages are regular or not. See, from the previous discussion I have already taught you that if a language is infinite but we are able to construct a regular expression for that, then the language is regular. So please take have a practice on this, right? So let's take the first question. It is given L is equals to A raised to M B raised to N, where M and N start from 0. See, there is no variable has been given. That means what? This is an infinite language. Now we have to just check it out. Here, we can deduce some regular expression or not. Or I am not deliberately focusing on how languages is converted into regular expression. That is the different issue. We will discuss later on in the different video, right? But we will have a close look on this, how we can predict that the language is regular or not, right? Okay, slowly we will understand. Okay, don't take so much burden on this, right? So what does it mean? It means the language may start from A0, B0, because I don't have any restriction of M and I don't have any restriction of N. So maybe it starts from A0, B0, okay. Next A0, B1, right? Next is what? A1, B0. Next is your A1, B1, right? Okay, now we are getting something. Next, what we can get? A0, B2, A0, A1, B2, A2, B2, right? Similarly, what we can take? We can take another A0, B3, like this, okay? So, and it goes to infinity. Suppose it goes to infinity. So what deduction we will get from here? What is A0? I have already told you A0 is epsilon, right? So epsilon into epsilon, followed by epsilon. Epsilon followed by epsilon is epsilon itself, correct? So first will be your epsilon only. Okay. What is your A0, B1? A0 is epsilon, B raised to 1 is B. So epsilon B is equals to B itself, right? So this will be your B. Next, A1, B0. A1, B0, A raised to 1 is A only and B raised to 0 is epsilon only. So A epsilon is equals to A only, right? So this will be your A only, right? Next one is your A1, B1. That means it will be your AB only. Next one is your A0. A0 is epsilon and B raised to 2. That is BB. Next A, B, B. From here, next A, B, B, and so on, right? So ultimately, what conclusion we can conclude? That is, it may be called as AB ka whole star. Why AB ka whole star? Because I am taking any instance of B followed by any instance of A followed by any instance of B. So there is no restriction on power. So this language can be rewritten as AB raised to power clean closure of AB. That means the regular expression has been constructed. It means this language is regular. Correct? Okay. Come to the second one. What is the second one signifies? Second one says that I am having A raised for M, B raised for N and C raised for O, where I don't have any restriction of anything. It starts from 0, means 0th instance of ABC, and it goes to up to infinity. That means this language is again, it is your infinite language. But through the previous discussion, we can conclude for this thing, that is, this will be any instance of A, any instance of A, for this I am giving any instance of A, followed by any instance of B, followed by any instance of C, and clean closure. That means again, for this example also, we have constructed a regular expression. That means this is also a regular language. But Come to the third point. Come to the third point. Third point says that means first instance will be your, what will be your first instance? A0, B0. For the third one I am explaining, right? Please remove this arrow because for third one. Second will be your, as per instruction, A raised to M, B raised to N. यानी कि second one will be A1, B1, third will be A square, B square, fourth one will be A cube, B cube, and A4, B4, B4, and it goes up to infinity. Why infinity? Because here it has been written that it starts from 0 and goes up to infinity. Now, finally we will get the string as epsilon only. For this I will get epsilon A B B. From here I will get A B B. From here I will get A B. From here I will get A B B B. From here I will get A B B B. Now see, this language shows, although this is an infinite language, but this language shows equal number of A and equal number of B, right? But in my previous lecture I have already told you that finite automata is not having temporary storage. That means the language which is having equal number of A's and B's is not called as a regular language, because finite automata has to have some stack to store this language, and automata is not having such language. So how this language will be accepted by? It is a language, but this is not a regular language because it cannot be accepted by a finite automata. The reason is what? To recognize this language, finite automata have one memory, so as to count the number of A is equals to the number of B. That is why this is not your regular language, right? Come to the fourth point, very important. Same case is there. A raised to power M, B raised to power M, A raised to power M, B raised to power M, but M is less than or equals to 5. What does it mean? Let's see. So let's talk about the fourth one and check it out that this language is regular or not, right? So here it has been given that L is equals to A raised to power M, B raised to power M, where M is less than or equals to 5. Now it is very much similar to this language, that is L is equals to A raised to power M, B raised to power M, where M is greater than or equals to 0. Fine. So what is the basic difference between these two languages? This is an infinite language, right? Why? Because it is starting from 0 and it is going to end. So this is your infinite language. But here, this is your finite language. Why? Because it will start from A0, B0, and after some instances, it will end up with A5, D5. Right? I am giving you an example. Like, first will be your A0, B0. Right? Second one will be A0, B1 up to A0, D5. Right? After completion, it will start from A0, B0 to A1, B5. Right? Next, it will start, I am just putting comma everywhere. It will start from A2, B0 to A2, D5. Next, I am writing downstairs. A3, B0 to A3, D5, right? And similarly, just again I am putting the comma, right? Now it will start from A4, B0 to A4, B5, right? And last will be your A5, B0 to A5, B5. So after this A5, B5, I cannot proceed, right? I cannot proceed. That means this limits up to this A5, B5. Yani ki this language is known as your regular language, or this language is your finite language. And I have already told you, if a language is your finite, then it is a regular language, right? Okay. Now come to the fifth part, right? I'm just rubbing it and I'm discussing the fifth part. Okay, fifth part is A0BN, and then M and N start from 0. So now see the situation. This is the fifth part. Here the language is given A is for M, B is for M, where M and N are starting from 0, and this is your infinite language. But here we have to see one thing, that we don't have to bother about whether M must be equals to N. We don't have to bother about M must be equals to N. That means M may be equals to N or may not be equals to N. So such type of infinite languages is a regular language. Why it is? Because sometimes what we can get A raised power 2, B raised power 2, or A raised power 3, B raised power 3, or A raised power 4, B raised to power 4. But it is not mandatory. It is not mandatory that the number of M must be equal to the number of N. It may be or may not be. So such type of cases, when we are having no constraint at all, in that case, if a language is infinite, still that language is regular. Why? Because on this basis we can construct finite automata. See, construction of finite automata through regular language, I will make the separate video, right, later on. But this thing must be clear to you, how we can predict that a language is, whether it is a regular or not.